Hey y'all, it's your favorite Miss Harper here for Multiplying Binomials. Alright, you're going to be needing to take these on your own sheet of notebook paper. We are going to need to remember our exponent rules too. So let's just review real quick, talk about our exponent rules. So if we need to, again, pause the note video, write this down if you need to, and then hop back on with me. So we need to distribute this thing. This is -3 times a 1, which is -3. M squared times m squared. Now you have to think, what are those exponent rules? So m to the second times m to the second equals m to the fourth, because when we're multiplying things of the same base, we add their exponents. Right, then I need to distribute this guy again. -3 times 3 is -9. M squared times m to the first power is m to the third power. And last one, -3m squared times -3. -3 times -3 is a +9. M squared, and that is our final answer. So now you see why we learned our exponent rules first before we started this unit. Good news is, for the most part, we're just going to be handling the product rule. So it's just where we multiply things of the same base, we add their exponents. And don't do this one. Let's look at this first one. Alright, so what we're going to do here, now we have two terms that we're going to be distributing. So for example, if I said we had something like this, I know y'all would know how to handle it. We distribute this term here and here. So this time we're going to be doing what I call double distribution. Double distribution. Some other terms you might get it or hear it called is FOIL. And that stands for first, outer, inner, and last. But I don't love that acronym because I think a lot of times students get caught up in the acronym. I just want you to think we're going to distribute both terms in our first parentheses to both terms in our second parentheses. So follow with me. Now another way you can also organize this, and this helps for some students, is what we call the box method. So you draw your box and then you write out your two terms. It doesn't matter which order you put them in. This is 2n plus 1. I could have also wrote that here first. And then this I'm going to call n and -4. Alright, and I'm going to kind of do both of these together. Alright, so first thing, I'm going to distribute my first term to my first term, and that's where this comes in. Alright, so 2n times n is 2n squared. Our next one, I'm going to distribute our outer. So this is our outer term to our outer term, and that's where this thing comes in. So 2n times -4 is -8n. Alright, then we do our inner terms. These two here on the inside. So this is a +1 times a +1 times n, which is 1 positive n. And then we handle our last terms. We distribute our last term to the last term. 1 times -4 is -4. Now I could have wrote these same things here in this box. 2n times n is 2n squared. N times 1 is 1n. 2n times -4, -8n. And -4 times 1 is a -4. Now in this step, we can go one step further by combining like terms. 99% of the time, these two middle terms are going to combine together. So we get 2n squared, a -8 and a +1 is going to become a -7n minus 4. Now you get the same answer had you done this over here with your box method, and we combine these two terms, and we'd end up here at the same answer. So whichever method works best for you, you can rock it that way each time. I'm going to be honest, Miss Harper does it this way. So you'll see this on the next couple examples, but if you want to pause your video and draw out the box, you can do it that way too. Alright, next example, and we're going to skip that one. And we're going to skip that one. They're all kind of the same. Alright, but I do want to look at this one. This one has two variables in it, so pause your video, write down your example, and let's try it out. Alright, so again, distribute my first term to my first term. 2s times s is 2s to the second power. Also, let me warn you too, a lot of the times I'll see kids just automatically draw all of their arrows. I don't recommend that you do that. I recommend that you draw your arrows one step at a time, okay? So here comes our second one. 2s times 4t. Well, 2 times 4 is +8. and s times t is just st. All right, let's distribute our second term. Now, don't forget to include his sign value, whether that's positive or negative. This is a negative 3t times s. That's a negative 3ts. All right, and then our last term, we have a negative 3t times a positive 4. That's a positive 12t. Again, our two middle terms are going to combine together. Even though this says st and this one says ts, they're still the same thing. It's like saying 2 times 5 is the same thing as 5 times 2. All right, so we end up with our final answer, 2s squared. These combine to a positive 5. Now you can call it st or ts, whichever one works better for you. Oh, and I actually made a mistake here. Negative 3t times 4t is actually 12t squared. 12t squared, because t times t is t squared. All right, there is one just like this on your practice. All right, we're going to go, let's just run through this one real quick. All right, same thing. All right, distribute your x to the x. We get x to the second power. X times a negative 5, that's a negative 5x. Positive 5 times x is a positive 5x. And then 5 times negative 5 is just negative 25. Now look at what's going on here with our two middle terms. What's negative 5x and positive 5x? 0x. Okay, so you could write in 0x, but what's 0 times anything? Well, it's just 0, right? And now some students, I'll see them want to write like that. They're like, okay, well, it's 0x. I'm like, well, what is this actually representing? Well, that's actually representing a 1x, so don't write that either. Essentially, these two things are going to cancel each other out. We're left with x squared minus 25. This is called the difference of perfect squares. We will learn about this later. All right, I'm not going to work this one out, but just make a note here. This is not power to a power rule. Power to power rule, like we saw in our exponent unit, and that's because of this plus sign in the middle here. All right, so we must expand it. So just like x squared equals x times x, we do the same thing for this. We're saying this thing times itself. So I need to expand it like this and say, okay, it's this thing times itself. And then you can do your FOIL or your double distribution. Okay? Again, I'm not going to work that one out. All right, last example. I just wanted to see want to show you guys how this can show up in a word problem format. So this is the area of a rectangle. To save you some time, you can just draw a rectangle here, give it a length of 4h plus 1 and a width of h minus 5. All right, so if area equals length times width, well, essentially all we're going to do is multiply these two things together, or double distribution. Make sure you toss them into parentheses, and then you can do your thing. So why don't you pause the note video, try this one out on your own, and then you can unpause and see if you got the answer correct. All right, if you're coming back on with me, hopefully you got here to this answer. All right, a negative 20h and a positive 1h lands us at a negative 19h. So high five yourself if you got that one right. Hop onto your practice assignment. Don't forget, pay attention, read the instructions on there too. It'll say, hint, watch out for ones that are not being multiplied. So remember to know the difference between something, know the difference between whenever we're doing something like this, where there's a multiplication in between, versus something like this, plus this. And in this case, we just combine like terms. We have two h's, and 5 minus 3 is a positive 2. Or, kind of the opposite, if I have this minus this, and again, you will see these on your practice, so be careful. I need to distribute my negative sign first. Minus h plus 3, and then I can combine like terms. H minus h, those are going to cancel each other out. 5 plus 3 is 8. Okay? So watch out for the positive and negative versus the multiplication. Good luck. If you have any questions, come see your favorite teacher.